we're going to talk a little bit about graphing quadratics in factored form. We've already talked about standard form and vertex form. Now we're going to talk about factored form. So what factored form is when I have two factors, x minus one number and x minus another number. Those r and s values that are written right here are your factors, which in turn are our x-intercepts. Our a value still tells us if our graph opens up or down and has a minimum or maximum. And like I said before, vertex form and standard form tell us different things, but those r and s values up here will give us our x-intercept, our zeros. So if I look at this graph, I can see I have two factors, x minus 2 and x minus 5. If I look at my graph, I see I have x-intercepts, right? Because I cross my x-axis at 5 and 2. What you should notice is that there's a minus sign here in each of these, but my x-intercepts are both positive values. So you need to remember to take the opposite of those values inside your parentheses. When I think about it, and what a lot of people recommend is setting those equal to 0, so that when you add the opposite, you get your positive value. Same thing here with x minus 5. I would add 5 to find my x-intercept. So if I look at this second graph, I see x plus 4 and x minus 3. So if I think about the opposite of x plus 4, that would give me an x-intercept at -4, or -4, 0, which we can see right here. Same thing with x minus 3. The opposite of a minus 3 is a positive 3, which would give me an x-intercept of 3, 0, which we see here. So if I look at some examples, I see the first question is asking me to label the x-intercepts. So the first thing you want to do is look at your x-axis on your graph and see where your function crosses that x-axis. If I look, I see my graph crosses the x-axis here at -2 and here at +3. So my x-intercepts are -2, 0 and 3, 0. I follow the same idea here. I label my x-axis. I'm going to highlight that in yellow. And then my x-intercepts, well, my graph crosses the x-axis here at 2 and again here at 7. So my x-intercepts are 2, 0 and 7, 0. I don't need to see the graph to label those x-intercepts like we talked about before, because I look at the values in the parentheses and take the opposite. So the opposite of a -5 would be a +5, which would give me one x-intercept at 5, 0. And the opposite of a +4 would be a -4, which would make my second x-intercept at -4, 0. And we can do the same idea here. The opposite of an x plus 2 would be x at -2 for an x-intercept of -2, 0. And the opposite of an x plus 11 would be a -11, which would give me my second x-intercept of -11, 0. We can also use these functions, these equations, and match our graph because we know where my x-intercepts will be. If I look at this first one, the opposite of a -1 is a +1, and the opposite of a -5 is a +5. So we're going to look for the graph that has an x-intercepts of 1 and +5. and I see that this one has an x-intercept of 1 and 5. So number 7 will match with graph C. Let's look at the same thing here. The opposite of a +1 is a -1, and the opposite of a +5 is a -5. And if I look at my graphs, I see that this one has an x-intercept of -1 and -5. So number 8 will match with graph A, which means number 9 should match up with graph B. So if I look here, x minus 1, the opposite of a -1, is a +1, which I see here. And the opposite of a +5 is a -5, which, oh, I see right there. So I know that graph 9 definitely, or equation 9 definitely matches up with graph B.